morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today I am going to discuss a topic about earthing design, which is from the subject Industrial Electrical Systems. These are the different topics which I am going to discuss. That is, what is earthing, what are its objectives, and what are the qualities and what is the purpose for this earthing system, and the electrical shock which may occur if earthing is not done properly, different types of short circuits as well as equipment needed, and the methods of different types of earthing. First one is the concept of earthing system. What is this earthing system? All the people working or living in residential as well as commercial or in the industrial installations, particularly the operators as well as the people who are doing the work in the low grades, in the close to the operation as well as contact with the electrical system. That means they are doing the electrical works directly. So for these kind of people, it is essential to be that they should be protected against different types of electrical shocks. To achieve this protection from, we provide a proper earthing system or installation should be done properly in order to prevent any hazardous effect. So what are the different types of standards or the requirements of this earthing system also to be known in this lecture? What is earthing? The process of connecting metallic bodies. The process of connecting the metallic bodies of all electrical apparatus or equipment to the huge mass of earth, by a wire having negligible resistance is called as earthing. That means a wire is being connected from the main circuit. Let us take, if some circuit is there which is having a resistor, inductor as well as a capacitor. Some circuit is being provided in a building, and this circuit should always be taken and it should be grounded or it should be connected to the earth through a wire which is having negligible resistance. Resistance means if any kind of fault occurs, the fault current will directly flow through this negligible resistance path and it will flow directly into the earth in order to protect the remaining device. So this is the earthing system. Here in the picture you can see, this is a 100 amperes of fuse, and here you can see 15 amperes of fuse, and if any kind of fault occurs, if any kind of short circuit occurs, the current flows through the ground. Here the grounding is being provided. To the secondary of a transformer in order to protect the device. The objective of the earthing. What are the objective of the earthing? It provides an alternate path for the fault current. That means the current may flow through the human being, or if at any fault occurs, the current will directly flow through the earth in order to prevent the current flow through the human body. In order to protect the human body, it will directly flow through the earth through this wire which is having less resistance or negligible resistance. So the objective of the earthing is to provide an alternative path for the fault current. If at any fault occurs, in order to provide a separate path for the fault current flow, we will provide a separate wiring or earthing system to fault current to flow, so that it will not endanger the user. It will not endanger the user, or it will not damage the remaining circuit. And it should ensure that all exposed conductive parts do not reach the dangerous potential. The dangerous potential they should not reach. The third point is to maintain the voltage at any part of electrical system at a known value, so as to prevent the overcurrent or excessive voltage on the appliances as well as the equipment. That means, in order to avoid this over voltage, or in order to avoid this excessive current flow through the different appliances or through the different equipment, to protect these devices, we will be providing this earthing system. What is good earthing system? Good earthing system means it should have a low impedance and it should be enough to ensure the sufficient current it can flow through it. That means the sufficient current should flow through the earthing system. In order to it should have a low impedance path. That means the wire which we are using for the earthing system should have a low resistance or a low impedance path. And that means the sufficient current can flow through the safety devices, so that it disconnects the supply less than 0.4 seconds. That means if the disconnection time is more than 0.4 seconds, it may damage the circuit. So below 0.4 seconds only, the circuit should be disconnected and the fault current should flow through the ground. So the fault current is much more than the full load current. As the fault current is more than the full load current, if this particular fault current flows through a circuit or a human being, a hazardous effect may cause. So the full load current of the circuit which melts the fuses. The fault current is more than the full load current, so it melts the fuse, and hence the appliances will be disconnected automatically from the supply mains. That means in this picture you can see, if at all any fault occurs here, the fault current is more than the maximum capacity of the fuse. So this will be open circuited. And the current flows through this. That means, and that should be less than 0.4 seconds of time duration. What are the qualities of the good earthing? What are the qualities are like? It should have low electrical resistance. As the current always prefers the low resistance path. The wire which is connected to the ground should have a low resistance and must be good corrosive resistance. Means mostly the earthing system is being provided in an open area, that is near the ground. So for different types of temperature condition, the corrosion may occur. So it should be corrosive resistant also, and it should be able to dissipate high fault current repeatedly. It should be able to dissipate high fault current. That is, when high fault current also flows through the wire, it should be able to bear that. So what are the different qualities are like? The resistance should be very low and it should be corrosive resistant. It can for that it should be able to resist for different types of temperatures as well as during wet conditions also, and it should dissipate high amount of fault current repeatedly or continuously also. So these are the different qualities. What is the purpose of earthing? The first purpose is to save the human life from the danger of electrical shock or death. From the danger of electrical shock or death, in order to protect, in order to save the human life, the earthing should be done. And it is used to provide an alternative path. It is used to provide an alternative path for the fault current to flow, so that it will not endanger the user. To protect the buildings, machinery and appliances. In order to protect the buildings, machinery as well as appliances under fault conditions. During the fault conditions, to protect them, we will be using this earthing system. And to ensure all exposed conductive parts. All exposed conductive parts means to this fault, if any kind of conductive parts are being exposed, they need to be protected and they need to be disconnected from the main circuit, so that the remaining circuit may not be damaged. And the third point is to provide safe path to dissipate the lightning as well as short circuit current. So the earthing system is used to provide or dissipate a separate path for the fault current. The fourth point is to provide a stable platform of operation. The fourth point is to provide a stable platform for operation of sensitive electronic equipments. That is, to maintain the voltage at any part of electrical system. That means for any level of the voltage, the whole system should be in a safe or a protective manner. In order to protect the equipment or in order to protect the circuit that may be of different voltage levels, the earthing system should be done. The last point is to provide protection against the static electricity from friction also. In order to provide the protection from the static devices, that is from the friction also. So these are the different purposes of earthing system. What is an electric shock? What is an electric shock? Electric shock occurs when two portions of a person's body come into contact with the electrical conductor of a circuit. That means whenever a person's body come into contact with an electrical conductor, the circuit which is at different potentials provides a potential difference across the body and the current flows through the body. The human body does have resistance, and when the body is connected between the two conductors and when the body is connected between the two different conductors at different potentials, a circuit is formed, and a circuit is formed through the body and the current will flow through the body. So when a human body comes in contact with only one conductor, that means when the human body comes into contact with only one conductor, the circuit is not formed and nothing will happen. That means when the human body comes into contact with a conductor in two different points, then only the shock occurs. If only one conductor is being connected, then electric shock may not occur, and it is not harmful also. Electric shock. The higher the potential difference, the more the damage. That means as the potential difference increases, the damage also increases. Then the electric shock, the effect due to electric shock also increases and is a function of what parts of the body come into the contact. So which part of the body come into contact, that is also important. And the resistance of each contact point of the surface resistance of the body, as well as the other factors. That means which part is being connected, as well as the based on the resistance of the body, the electric shock will occur. When the electrical content is such that the circuit path through the body is across the heart, the circuit is in such a manner, that means in the circuit, if the heart is also present, you may have a greatest potential of death. That means it is also important that which part of the body is being connected inside the circuit, and through which part of the body the current is being flowing is also important. Here you can see the picture. There are two different pictures of human body. Here in this human body, Z, you can see Z is equal to 500 ohms, depends upon the skin moisture and other factors. That means the moisture of the body, whether the body is dry or wet, based on that also the electric shock depends. For here there are three different categories, that is I is equal to 250 milliamps, I is equal to 550 milliamps, and I is equal to 960 milliamps. Means three different currents are being passed through the human body. The human body's resistance varies from low as 500 ohms to as high as 600 kilo ohms. 500 to 600 kilo ohms. So as the skin is moist due to sweat that contain salt, the resistance drops further. That means due to sweat also the body can become wet and the shock may increase. And the figure 1, the first figure, illustrates that the amount of current that can flow through the human body at three different potential differences across the body is being shown in the effect. That is different current levels, both AC as well as DC. The ultimate effect is, you can see here, see there are three different potential differences. This is the first point, this is the second potential difference, this is the third potential difference. So there are three different potential differences that are being connected here. DC, which cause the heart to stop and death in the result. That is the third potential difference is occurring through the heart. So this may cause death. The current through first as well as second may not cause the death, but the current which is passing in this way may cause death, because here you have your heart and here is the third potential difference. Short circuit. What is a short circuit? To analyze how an electric shock occurs and how grounding is applied, you need to look at the circuit here. Here you can see you have a fuse here. Here you have a transformer secondary where the secondary voltage is 120 volts. The 120 volts is being provided to the fuse and to the resistance R1 here, and which is connected in series. With the load as well as more resistance R1. So the current is voltage E, the total voltage divided by these three resistances. Here you have resistance R1, one more resistance R1, as well as the resistance of the load, you will call it as RL. So the current in the circuit is nothing but E divided by R1 plus RL plus R1. So the answer will be I is equal to E by 2 times of R1 plus RL. In the second picture, here also the voltage 120 volts is being connected, and here a short circuit is being occurred. And there are no resistances in the path. Most short circuits are high resistance and they have momentarily as well as intermittent. And the high resistance short starts out of high resistance or high impedance connections, but usually progress to the low impedance connection. That means as the current always prefers the low resistance path, so the current flows through the path where the resistance is very low. In electrical circuits, shorts are classified into phase to phase, phase to neutral, or phase to ground short. That means there are 3 phases for a 3-phase AC system. You will be having R, Y, B. 3 phases will be there. Phase to phase means between these two a short circuit may occur. You will call this as phase to phase short circuit. And the second one is phase to neutral. The fourth line, that is neutral, will be there. R, Y, B. These 3 are the phases and this is the neutral. So, if at all any fault occurs between any one phase and the neutral, you will call this one as phase to neutral short circuit. So, if at all any fault occurs between 2 phases, that may be a RY or YB or BR. This is phase to phase short circuit. And if the fault occurs between RN or YN or BN, that means phase and neutral. This is also phase, neutral, phase, neutral. So, this you will call it as phase to neutral short circuit. And if at all there is a fault occurring between the phase, any one phase and the ground. If at all any fault occurs between any one phase and ground, you will call it as phase to ground short circuit. Okay. So, there are 3 different types of short circuits which may occur during the transmission or the distribution systems, that is phase to neutral or phase to ground. Equipment earthing. In case of insulation failure, if any failure occurs during the process for the insulation, the primary object of connecting all these above points or the above phases and different apparatus to the earth is to release the charge. In order to release the charge, in order to flow the current, we will be connecting this earthing or will be connecting the circuit to the earth. What is the maximum value of earth resistance to be achieved? That means for low power stations, it will be around 0.5. The maximum value of earth reached by resistance in ohms is around 0.5. And for the major substations is 1, small substations is 2, factories is 1, and for steel towers it is 3, for industrial machine and equipment is around 0.5. And it almost depends upon the moisture content of the soil. So these are the values of resistance of the wire which is being used for earthing a particular circuit, which is used for grounding or for earthing the particular circuit. What are the different methods of earthing? What are the different methods of earthing? There are conventional methods as well as maintenance free earthing also. What are the conventional methods? The conventional methods of earthing calls for digging of larger pit into a GI pipe. Here you can see a strip here, that is the earth is being digged and a strip is being placed inside the earth, and the earthing wire is being connected to this strip. This type of earthing requires maintenance and pouring of water at regular intervals. That means water is being poured in this pit. So regular water should be filled with regularly this pit should be filled with water, and regular maintenance should be done for this type of earthing system. Maintenance free earthing. Previously was conventional earthing, now it is maintenance free earthing. That is, in this type of earthing system, which is ready-made, standardized and scientifically developed, it has a benefits that maintenance free, that means maintenance is not required, no need to pour the water at regular intervals of time. Next one is consistency. Consistency means maintain a stable and consistent earth resistance throughout the year. Throughout the year, the resistance will not change. And more surface area. The conductive compound creates a conductive zone. If this particular strip is being placed here, this is connected to this particular area or a zone. This you will call it as conductive zone, which provides the increased surface area of peak current dissipation also. And also get a stable reference point. Maintenance free earthing means low earth resistance, no corrosion, and lifetime is more and easy installation. Methods for conventional earthing. There are different types of conventional earthing methods. You will call it as plate earthing, pipe earthing, rod earthing, strip earthing, and earthing through water mains. So these are the different types of earthings which comes under the category of conventional earthing. Here you can see earthing electrode, plate earthing. Here you can see a plate which is being provided inside the earth. This is your ground level. Inside this ground, around 5 feet, we will be placing a plate inside this, and this plate is being connected to this rod, and this pit is being filled with sand, salt or water. So this is your plate earthing. This is pipe earthing. Instead of plate, we will be placing a pipe, and the gap is being filled with salt, coal, or for improving the soil conditions and efficacy of the earthing systems. So you can avoid the water here. Here you can use the salt as well as coal for filling the earth pit. So this is the second type of earthing. The third type is rod earthing. That means a rod is being placed inside the earth by digging the earth, and that rod is being connected to the wire which is connected to the main circuit. In this system, around 12.5 mm diameter solid rod is being used, and the material which is used for this is copper, mostly copper or steel or hollow section of 25 mm. That means with an of 25 we will be using steel, and for 16 copper we will be using, in order to increase the length of the electrode under the ground. In order to increase the length of the electrode inside the ground, which is sometime necessary to reduce the earth resistance. In order to reduce the earth resistance means, as the earth resistance reduces, the fault current which is flowing through the earth increases and the damage of the electronic equipment reduces. So in order to reduce the damage, we need to decrease the resistance, and in order to decrease the resistance, we need to increase the length of the electrode under the ground. So this type of earthing is suitable for the area which are sandy in character. This type of earthing is suitable for sandy type of earth, and it is very cheap when compared to the remaining two types, that is plate earthing and strip earthing. Next, pipe earthing as well as plate earthing. The next one is strip or wire earthing. Strip or wire earthing. All these type of earthings comes under the conventional type only. Plate earthing, plate or rod or pipe or strip, all these comes under the conventional type of earthing, where they require regular maintenance. So in this system, that is strip type of earthing, a electrode of cross-sectional area less than 25 mm into 1.6 mm of copper or 25 mm into 4 mm of GI or steel is being buried inside a horizontal trenches with a minimum depth of 0.5 mm. That means inside the earth, a cylinder type material is being placed. Inside that, a strip is being placed. To this strip, the earthing wire is being connected, and the length of the buried conductor shall be sufficient to give earth resistance. The earth resistance is around 0.5 to 1.5 ohms. So in order to provide a resistance of 0.5 to 1.5 ohms, it should be buried properly at a proper depth from the ground. So it should not be less than 15 meters. That means below the ground level, it should be more than 15 meters of length. The electrode shall be as widely distributed as possible in a single straight or a circular trenches radially from the point. So this type of earthing is used in rocky area earth. It is mostly used in rocky area earth, because at such places excavation work for plate earthing is difficult. So in this type of earthing, strip type of earthing is mostly used in rocky soil, and rod type of earthing is mostly used in sandy type of earth, sandy type of ground. What are the applications? What are the different applications like? First one is telecommunication. The second one is for transmission of the power. The third one is substations as well as different power generations at different substations and power generating stations also will be using this earthing systems. And transformer neutral earthing. That means for every street as well as for every building, we are being connected with this transformer, and for this transformer neutral and earthing system should be connected. The next one is lightning arrestor earthing. That means in order to reduce the lightning effect, which is caused due to lightning strike, we need to provide a proper earthing. Next one is equipment body earthing. That means each and every circuit or each and every equipment which is used in a building should be connected to the main earthing system. Next one is water treatment plants. In order to purify the water, different water treatment plants are being there, and for all these plants, the earthing should be done properly. For heavy industries, heavy machinery we will be using in the industry. In order to protect these heavy machineries from different types of faults, the proper earthing should be done. Next one is colleges, hospitals, banks, schools and residential buildings. So these are some of the applications where earthing is compulsory. In next lecture, I would like to discuss about the power factor correction and kilovolt ampere reactive calculations. Thank you.